Hi everyone. Could you hear me?
Yeah, we can hear you, Professor.
Yeah, we can
Okay.
hear.
So let's start. Uh, thank you for taking time off on Sunday. Okay, let's. I know I had a lot of things I was in the middle of doing. I imagine you also were. Uh, is anybody trying to join? Uh, just see if anybody waiting to join. No. Okay. Yeah, it's sort of messed up. Okay. Okay. So let's do it. So let me go here. 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 Okay. Okay, here we go. So, uh, I'll just start at chapter one and go through it. Okay, so basically we're just reviewing all the folders and uh, we'll do it as quickly. And okay, so um, actually let me skip to uh, okay, over here. So what is software engineering? So software engineering is not programming, but rather the idea is that you're managing a project, a software project. Okay, anybody want to answer? What's included in software engineering?
Basically everything besides for like the financing and the
Exactly. Very
yeah, the
good.
advertising.
Right, very good. Anything answer? Right. Oh, you're reading that. No, you weren't reading that, but good.
I
Okay,
wasn't.
that's very good. Okay, very good. Okay. Uh, okay, then we went through uh, okay. In general, these are whenever you're developing a software, no matter which method you use, you're going to have all these steps, right? So, and there's any process that you're going to use is going to go through these steps, which is number one, feasibility. Number two is requirements, design, or architecture, coding, programming, development, and implementation. They're all the same thing. And we said that unit testing are written by the developer. And then there's testing, which is non-programming, right? Meaning non-programmers do it. And then and sometimes it's called QA, though QA is really something different, a little bit different than testing. Um, and then we have the release and deployment, and then documentation. You might you might put 7 before 6, but it's not that, and then you have evolution or maintenance is where you make a new version of starting from, you go through you would start through all the steps again. Okay? So far so good?
But
Yep.
Good? Okay. What is not involved? We just said that those three, like this example, three things: hardware, financing, advertising. How has technology affected the software process? At the time I wrote this, I don't even know if I realized how much AI would change things, though I don't know if it's changed it as much as people think it has, but it's really, in my opinion, it's just a a faster search. Like it's like a better search. Doesn't really, you still gotta understand what you're doing. It's not like you could, you know, like I've had discussions with other people who say the AI could, you don't even have to look at what it did. Just if it works, it works. And I don't know. I don't trust it that much. Okay, it's like to me, if you don't look at the code, understand what, you have to, it's good if it's okay if it wrote the code for you, but if you don't understand what it wrote, then I don't know. That's an argument between different programmers, different opinions. I personally, my belief is that you have to understand what it did or don't use it. Uh, Other people, like one person I spoke to, said, "Well, I wrote six scenarios, and it did all those scenarios correctly. So, in my opinion, it works. Do you understand what it's doing? No. So, whatever. So that's a difference of opinion whether AI is actually um, if you can let it develop on its own, or do you have to understand what it's doing? Currently, it's really not so good that it could actually. It usually needs to be tweaked. So it's very rare that unless it finds a program somewhere that someone already wrote that's exactly what you're looking for. But in general, it needs tweaking anyhow. So you do have to understand what it's doing. Anyhow, maybe in the future you won't. Okay, anyhow, so B, different platforms or operating systems, because it used to be that you would just have a couple things. Now we have all these different um, platforms that we have to software runs on. C is that because of the internet, everyone in the world is a potential user. Um, I should maybe put that in there because of the internet. Okay. Reduced delivery window because we have all this competition. So um, there's a pressure to release software quickly, and security because software could be is worldwide, so it's open to the world. These are different words, buzzwords. So um, performance refers to that it runs quickly. Usability refers to how easy it is to use. Reliability, is it dependable? Functionality, we said there's two types of functionality. The functionality refers to requirements, right? But we said it refers to two different types of requirements, either functional, which is what they ask for, and what the user asked for, or non-functional requirements, we said are requirements that are like they're more important than functional, meaning because they're more basic, they're like encompass more than one specific requirement. It's sort of like a general type of thing like security, performance, something like that. Okay. So for example, performance, this is a non-functional requirement, right? Functional. That's a good example of a non-functional requirement. Because that's something that's not one specific feature usually, but it's the whole program has to be quick, right? Usability is also a non-functional requirement, right? Do you understand why usability is a non-functional, right? Right. All these things, one, two, and three, they're all non-functional, right? So I'll just put that here. This is also, so all these things are non-functional. Reliability, because these are things that affect the whole program. It's not one specific requirement, you know.
Is it like non-functionality is basically just things that are so regular that they should just be assumed or they're expected?
Yeah.
Yeah,
Yeah,
that's how I
I
think of
mean
it.
that's another way of saying it. Yeah. Um, yeah, yeah, that's a good way of saying that. Who was that? Yeah,
That
yeah,
was me. Just how I think about it.
yeah, yeah, that's the way I understand it also. Like it's like something that they don't mention as a requirement because they just assume it. Because you can't say every single thing, you know, some things are assumed, you know. You can't spell out the definition of every word in a contract. Otherwise, it would be, you know. it would be, some things are assumed, right? Um, okay, maintainability means that it's easy to fix, the code is easy to fix. So I wrote comments, but really clean code is more important than comments, right? So it's really clean code is the main thing. Um, Comments, um, like where I work, we don't put in comments so much because um, well, it should be limited because um, code is modified, but people forget to um, or they just don't care. They just they forget to update the comment. So that's basically what you see in code is so comments in generally is not a good idea because it sounds like a good idea, but then when no one updates it, it's kind of ridiculous. Okay, security means again that we're protecting the data, and safety means we're protecting the users of the software that they don't get harmed. It's a little bit different idea, right? It's basically nearly all these things are non-functional. It's interesting. Okay. Um, yeah, so okay. Different types of software. We end up chapter one with this, which is we said there's standalone, which is basically there's no network required, transaction based, meaning that it's data is saved. And when we save data, we said that we want to save either all the data or none of the data. Embedded software means that software that um, that communicates with hardware, meaning that it directly it's inside the chip or speaks to the chip, so it's expensive to what's interesting about that is that it's expensive to modify because it's connected to the hardware. Um, Web software is always the architecture is always going to be client server um, architecture. I mean, just that archi. I don't know if I'm spelling this right. Okay, this fixed it for me. Game software, graphics are critical. Financial software, it's important to always be accurate when dealing with money and sometimes speed, right? Like for the stock, like New York City, um, that if you work on Wall Street, speed is important. Okay, okay, so that's that. Um, Next, let's do class two. So I'm just going through the classes. Um, I think this is just the same thing again. Class three. Um, okay, so here let's see what we did here. Okay, so here we spoke about UML, and we said UML stands for Unified Modeling Language. Remember, I told you it was there were like four different ways that um, they used to exist, and then they got together, and they called them the Gang of Four, and so they came up with a way to represent things in um, in computer science, I guess. Um, the one that we started with was the UML class diagram. So first of all, we said that a object or a class is represented as a box with the name of the object or the class on top. These are, and then we have the data and the methods that operate on it. Okay, so that this is in the UML class diagram. This would be a class or an object. Okay, okay, good. Okay, no questions. Okay, so object-oriented programming. So in Java, an object is a class within a class, an instance of a class. So, okay, this is a little bit I mean, you should know this in general, right? That there's like for example, there's like a species of like of a lion, right? And then there's an actual lion, right? Let's say I have a pet lion called Tiger, and I have another pet lion called, I don't know, Tiger 2, right? So the species it is a the type is a lion, but the instance, meaning the actual um, insta in, in the actual object of that type is actually, has a name, right? So that's the difference between a type and an instance, right? So an instance is when a certain type has been created and it has like an actual memory address or a reference in a program. It has um, its own unique object. Okay. In general, the way you know whether a a type, there's two types. There's basically all classes can be divided into two types, abstract type and concrete type. And the way you know whether something is a concrete or an abstract is whether you could create an object of that type. Meaning if you could say new on that type. So so for example, um, if I have a um, if I have a list in Java, a list of something, let's say a list of animal, right? I cannot do let's say list. I cannot do this, right? I can't say new list of animal. It won't let me do it because a list is not a concrete type. Okay? I cannot do this, right? Right. So list is an interface and therefore the line below will not work. Okay, is that clear? But we could do something like this. We could say, in fact, I've done it in class. We could say new array list. So that it will let me do because this, even though the left side is a abstract type, but the right side is a concrete type. So um, I'd say array list is a concrete class, and therefore um, and therefore the line below will work. Okay, so this will work because I could say new on a array list because that is a concrete class. Okay, so that's basically how you would know. So we said that an object contains data and methods. Um, and we just said that what we just said. We said that an abstract type cannot be created using the new operator, meaning it can't be on the right side, but it could be on the left side. Meaning you could have a pointer on the left side as long as on the right side there's a concrete class. Does that make sense? In other words, you could point to a concrete class using an abstract type. Okay. Um, we'll probably go into this a little bit more. Um, okay, what is inheritance in Java? In Java, the way you say inheritance, you say B extends A means that B is A plus B's code, right? So meaning that A and B have a is a relationship, meaning that B is A, right? A is not B, but B is A, right? Um, the issue be, be, with is a relationship is that it's called tightly coupled, which means that they're very their relationship is very strong, right? Which is usually bad, right? Because the parent forces his children to act in a specific way, and the children only want to do one thing similar to their parent, not everything, right? And then we said another, so that's one issue. There, there is also, I should say, there's also a second problem. A major issue when adding, modifying either the parent or the child. Um, oh, okay. Um, right. So, okay. Meaning that actually, not there's also. So, um, okay. Well, okay. Okay. So, for example, if I there, okay, make it simple. So, changing anything in A may accidentally change. May accidentally. Um, not may accidentally will change all the children of A. Therefore, everything will need to be, therefore, everything in B will need to be tested every time a change is made to A. Also, changing B maybe it will be hard when it conflicts with A. Both have the same, i.e., both have the same method, doing different things. Okay, does that make sense? Does it make sense what I just said? You know, it's because you have this strong relationship. So, number one, B is forced to do everything A does unless B fights it. And number two, if you change A, you're going to change B. And if C inherits from B, you're going to change A. When you change A, you're changing B and C, right? So, no, it's will change. Okay. Yeah, get rid of that. We'll change all the children of A. Okay. So, what is the alternative to inheritance? So, we say that the alternative is to have loosely coupled code, right? Which is rather than be inheriting from an object, we just use to, we just use the parts of the code that that we want to use, right? And so so one um, So what one way is um so one way is called composition, where we have a has a relationship, meaning that um um you know what? Let's do I have them? Oh yeah. So if you look over here, okay, let's look over here. So over here we have an object called draw circle, right? And draw circle takes circle as a parameter. Okay. So draw a circle, um, right, only has to use the parts of, oh, wait a second. Oh, I see. Okay. So what I did here was I have a method called draw circle, and I take, okay, I see. Right. So, okay. So there's two different ways, there's two different objects that do the same thing, right? The difference is that one object is stuck you drawing a circle, right? Because over here, notice even though it doesn't inherit from a circle, right? Because the circle is really a part of it. So it doesn't, it's not forced to do everything that circle does, because it even has a square inside of it, right? But but the problem is that it's still relying on this concrete object, right? So this is pretty good because there's no inheritance, right? But and so since there's no inheritance, the draw circle has the freedom to do whatever it wants. Whatever it only has to use the parts of circle that it feels like using, right? So it doesn't. So that's good, right? But it's not as good as this one over here because over here it's not it's not it doesn't have to it doesn't have a method called draw circle, but rather it has a method called draw. And so whatever type I pass into it, it will draw that type. So this way over here is a lot more it's it's a lot more open to to um it's the least, in other words, draw a circle over here requires a circle in order to draw, right? Over here, draw using interface, it doesn't require a a circle, or it just requires something that has a shape interface. And as long as it has a shape interface, then it could draw that shape. So, so the worst, so we'll go from bad to worse. So the worst would be, the worst one would be extends circle. Okay, so this would be the worst because, and then we have a method called draw. Okay, okay, so let's go from bad bad to better. So we have the worst. This is using inheritance. So it is bad, right? So this is the worst, right? Okay, this is the worst. Okay, this is better because it isn't using inheritance. So it only, so draw a circle only uses the parts of circle that it wants to, right? So it's not forced to do anything it doesn't want to do. Let me just plug in my computer before the battery dies. Hold on a second. My- Okay, so it's better because, um, but it's still not 100%. Um, but it still has um, it's still the but still it's but even though it's not doing inheritance, but still relying on a specific class called a circle. Okay, so we could even do even better because when we get over here, this is the best. So this would be the best way to do it because it's number one, it isn't using inheritance, right? So that's good. But it also is not relying and it's not relying on any specific class. It can draw any object that um, has the draw method. Okay. So everybody see this? The worst is this one because this one is stuck to circle, right? Draw a circle is stuck to circle, right? It there's nothing about right. For example, you want to draw a square, forget about it, right? It's stuck to circle. Okay, here we're sort of not stuck, but if you notice, we're passing in circle, so we're sort of we so in a way we don't have we're not inheriting from circle, but we're still passing in a concrete type. So but the best way is over here where number one, we're not doing inheritance, and number two, the method we're using doesn't use a specific type, but rather use a abstract type of shape interface. So which could be either a square or a circle, right? So we could do something like this. Um, we could have new square or new circle, and it will work, right? Right? We could pass in anything we want, and this will work. Over here, we can only pass in the circle. Okay? So the best is this one over here. Okay? Any questions?
Professor, is the
Yeah.
second way using composition or no?
Yeah,
So the second and the third way are both using composition,
right,
but the third way is just better.
because circle is inside of and so it's part of it. It's not inherited from it, right?
Okay, so as long as it's not inherited, it's using composition.
Yeah, basically.
Okay, I see.
Right. And actually the third way is this is a strategy pattern.
Yeah, yeah, because it has observers, right? So interface basically
Because we
means
could pass
strategy.
in either a square or a circle and without changing and without modifying any of this code. It'll draw either of them, right, without modifying it. Right? We can pass in square, circle, as long as they have a draw method, they will work.
So basically, like just using interfaces basically means you're using the strategy pattern.
Right.
It
Right.
doesn't,
Well,
I thought,
using composition and yeah. Uh,
yeah.
yeah, composition with inter right. That's right. So this is composition, but it doesn't have interface. This is both. This is using composition and interface. So that's the strategy. Okay.
Yep.
Okay. Okay. So let's um look over here, what I put over here. Um, yeah, I don't want to go through all this stuff. So basically, it's basically what we just said. Okay. So, um, okay, so we're up to class 4, I think. Okay, so we said strategy pattern. So let's look at that. Um, actually, let's just, so basically the strategy pattern we said was that, um, we're, actually, let me just open up my computer over here. If I could find it. Okay, strategy. Uh, oop, singleton, solid server. Here we are. Okay, so basically, the strategy pattern is that we have a duck and the duck. Oh no, what's it called? Oh, oh yeah, the strategy duck. Okay, so basically, the idea is that this is a strategy pattern that we have a duck. And I just call it strategy duck because of the other way of doing it. But the idea is that we could that this doesn't change, meaning that as long as we pass in a type of behavior, meaning of how to fly and how to quack, right? Then then this will be able to quack and fly without um, without having to modify any of this code, right? So we have like over here we have quacking, which is interface, and then we have no quack, which is implements interface. So all these are all different types of behavior we could pass into. So for example, over here, we could do a regular duck. We pass in quack and fly. That's like a regular duck. Then we have a do nothing duck, which doesn't quack and doesn't fly. And we could pass that in. And then we could have a duck that only flies. So we pass a no quack and so we're having all these different options, right? But we're only, but the idea is that the strategy duck does not change, right? We don't have to modify the code because what we're doing is we're passing in the behavior that changes. Okay? So I think that's what we're going to see over here. If we go back to here, we're going to see, I hope. Oh no, that's not the wrong one. Right one. This should be. Uh, here. Let's see what we did here. Okay, so so we have two. Um, so the idea of the strategy pattern is we say that we separate behavior that changes into its. Okay, I'll trust them that that's the correct way to spell it. Its own object that can be passed by itself. So the idea is that we don't want to change our code, but rather we want to add code. So we so there would be number object-oriented principle number 6, which is open for extension, closed for modification, meaning that we don't want to keep changing code, but we rather just add new code when we have new behavior. Okay, but the duck itself, we don't want it to change, right? Just like over here, the duck, if you look in main, the duck itself doesn't change. Rather, we're just passing in different behaviors. So that's object-oriented principle number 6. I just called it number 6. There's no real yeah. So that's the number I gave it. What is object-oriented principle 1 through 4? Why do I start at 5? Do you remember? Right, so we said that the first f four are the standard ones, right? Um, Encapsulation, inheritance, abstraction, and polymorphism, right? Right. Then we start with the more complicated ones, which is number 6, open for extension, close for modification. 5, prefer composition to inheritance. Okay, that we rather use um we don't like inheritance, okay? Because it's just a mess. Um we did this, uh we did that. Okay, this is all basically oh over here we did the first four. Um I think the next class I'll have it better. So let's do class 5. So over here we have the first four principles, which are encapsulation, which means protect the data, which, what does that mean in practice? In Java, how do you encapsulate data?
Just make it private.
Right, and then how do we expose it?
Was it like getter methods or
Getter and setters, right?
yeah?
Okay, inheritance means that we basically inherit. Polymorphism means basically, like we said, like we allow to use the same method with different number or type of parameters. Abstraction means any method which does something. So that's abstracting because when you have a method, it inside an object it does something for me, so I don't have to know how to do it. Um, and we said strategy pattern, and then okay, so this is all we did. Okay, okay, so that's that. And what is this over here?
Will on the exam, will we have like code segments that we have to like determine like which of those principles it's using or like what design pattern is using or something like that?
Yeah, maybe a little bit like that, not a lot.
So not a lot of like code
It's like
segments.
simple stuff, like nothing, yeah,
Okay. All right.
nothing, yeah. It might be like 5 lines of code and say, it'll be pretty obvious.
Okay.
Okay. What is this? I don't know what I'm doing. Okay. Log error shape. Checking. I forgot what I was doing. Oh, I was probably doing the solid principles. Okay. So, uh, let's see if we want to look it up here. It's probably the cell. I think I saw it. Recent. So we had uh, we just did, uh, we did I'm trying, I'm not sure which one. However, we probably wanted to do this one, which is the four object-oriented principles, which is basically, yeah, this is it. So basically, we have this is an example of encapsulation, right? We're protecting the balance, which is private, right? Over here is a checking account, is example of inheritance. Log error is an example of uh, uh, I don't know. I forgot what this is an example of. Do you? Um, oh, it's because I made this private, so maybe that's encapsulation. Uh, so what was other? Oh, maybe it's just maybe the point is that the log method is abstraction. Maybe that's what I was trying to say. And then the shape is doing the draw. I don't know. Oh, yeah, this is print line is example of polymorphism because over here you have the same method name, but you have different parameters, right? Um, So it's and then abstraction is just this example of I think it's pretty obvious, right? What the four object-oriented principles are, right? So this is um, this is example of encapsulation. This is example of inheritance. This is an example of, I'm not sure, maybe abstraction because it does something for me. It knows how to log an error. And this is an example of polymorphism because the print line could take different parameters. Could take a string, even though it's the same name, but it's actually, in reality, it's really a different method. But it hides that from me, hides it from the user. Okay? So that would be that. And then class six um, would be, let's see, class six. Oh, yeah. So class six, we started doing different process models. So we went through um, the different pluses and minuses of them, right? Um, and then we said that there's three of them. So basically, of the waterfall, where we do all of them in order. Um, what doesn't like? Okay. Um, it's interesting. Google Docs has different, has different, like I did this originally in Word and then I uploaded it and then Google Docs has their own, um, you know, autocorrect. Anyhow, so this we said this basically we're going to cover three models. One is waterfall, where you do things in order only once. Incremental, where you repeat the steps over and over again. And then reuse is which the book calls integration configuration, where we just do requirements, feasibility requirements, and deployment. We don't have to do the middle part, right? We just have to decide what we're looking for, find it, and then use it. We don't have to test it. Uh, there are three. Yeah. Okay. Yeah, I don't. Yeah. Okay. What's going on here? How do I get rid of the header? Uh, so there's too many things going on here. Just hide this. Uh, let me just close this and reopen. Okay. There we go. Um, Okay, so okay. So basically, we went through the benefits and the downsides of each one. So the thing that you should remember, very important, is what is the downside of the waterfall and the benefit of incremental? Does anybody remember?
Waterfall is like really hard to change because changes are expensive, and incrementally you can like change and test along the way.
Yeah, but that's not the most important part.
Um,
The most important I said was what? That that the waterfall is you're only doing the coding at the very end and then you're stuck, right? Whereas if you allocate a certain amount of time for your project, as if you have unlimited time to do a project, so then you don't care about waterfall. Waterfall might be good for you. But since most projects have an end date, right? So if you do the first parts of it, meaning you do the requirements and design and then you do the last thing you do is the programming and the testing, right? What happens if the coding takes longer than you think it will, right? Then you're out of luck. You got to throw out all your code, right? Because you have nothing working, right? And you have all these things to do and you haven't done it. So typically it fails or it goes over budget. But with incremental, though, I'm doing everything a little bit at a time. So I get to estimate. Basically, my progress is predictable. Does that make sense?
Yeah.
Meaning with waterfall, I really don't know. I really can't predict how long the coding is going to take. Actually, I don't know. I really can't predict anything because I'm in the middle doing requirements. So I can't really predict the other steps till I start doing them, right? So, but with incremental, I could predict at the end of every increment, I have a version that works, right? It's been fully tested and works. So because of that, I could predict what I could do, and I know I'm confident that even though I can't do everything, but at least I know that 3 years before it happens, right? That what I could do, what I can't do, right? But waterfall, you only find out the last, the last minute or the last year, right? You spent 2 years, 1 year doing requirements, 1 year doing design, and then you have 1 year left to do everything else, and then you realize that you need more than a year to do it. So then you're stuck. But over here, you're able to every month I'm doing a little bit of everything. So so right away I get very good at predicting what I could do and what I can't do. So then we can make changes way before the project, gets killed. Okay? So and which one of these three is the best in general? Or nearly
Reuse,
all? What?
reuse in general for
Right.
like modern projects.
Right, because reuse is always good because you're skipping all the steps, all the pain, right? You only have to do requirements and you know and maybe configuration. That's it, right? Or integration, right? You don't really have to do anything else. So, right, all you have to do is look for software and then you either configure it or you adopt it or you add it into your system, right? But basically, you're not doing there's no coding, there's no testing, there's no you know design, right? You just take it as it is and you hope it meets and you find something that does, let's say, 95% of your requirements. Okay? So that is so reuse is always the best way to do it because you're saving a lot of money, but it's again, it's not for the right. And then we went through all the reasons um, and downsides of each one. So basically, I'll just read these quickly. Waterfall benefits um, uh, is whenever it's expensive to when it's too expensive to go back a step. For example, it's either hardware or there's regulation. So we only want to do something once, then where it's very expensive to change the requirements after we begin. So then we would want to do waterfall or contractual because when you write a contract, the requirements with waterfall could be the contract, right? No, it's when somebody's paying me the money, I'm giving them all the requirements that we're going to do, right? But with incremental, we don't have that when right at the very beginning because we're coming up with the requirements as we go, or at least some of them. Also, when you have many works working together, you need to have everything up front. You can't have one group changing stuff while which will mess up the other groups. The downside is, like we said, there's no place to make changes. Two was the main thing that it's hard to estimate how long a project will take. Three is that there's a scheduling issue because if everybody is doing if you're only doing one thing at a time, then what are the programmers and the testers doing while you're doing requirements? So it becomes a scheduling issue. The benefits of incremental is number one, it's how people think. The paths make a change, but the main thing is number three is we able to predict the progress. And number four is also since every iteration we have a new working program, we can do early deployment. The downside is well, we can't. Um, we can't it's hard to write a contract with incremental because um because we're allowing changes to creep in. Um Number two is every time you make increments, you're always changing existing code. Um I mean, even though theoretically, if you use the strategy, you don't, but you can't do everything with a strategy pattern. So you are going to be making changes, and will that will make the code messy. So it has to be the code has to always be fixed up. Um, Number three is they're more of a trees in the forest that you're looking at your 30-day increment or cycle, and you're forgetting the overall design. The reuse model is it's cheaper. And the downside is number one, I can't change the code because someone else wrote it. So I might not have the code, or if I do have the code, I don't understand how it works. So number two, the person who wrote it might just stop doing it. And number three is licensing restrictions. So, for example, if I'm a private company and I don't want to, um, have I want the software to just be mine. So then I might not want to use free software. And then the V model we said is that similar to the waterfall, but as we're going down the waterfall, we're creating tests for each step of as we go down the waterfall, we're creating tests, and then when we hit the bottom, we have all these tests that we're going to do. Okay, and that's that. Okay, so that's class six. Wow, we did a lot in six classes. Class seven, we did the observer pattern, and basically the observer pattern we said is very similar to strategy, except that um, okay, let's just look at it in a second. Just need a drink. I also have some type of energy. Where's my water? Water. Water. Into that water. Um, okay. So I'll have to open up Observer. Okay. Okay, so where's my water? That's weird. Uh, I hit my water. Man, what? Okay. So um so over here, the idea is we have a stock market, but rather than keeping a different list of observers, it keeps one list of oh here. It keeps one list of observers, and what the observers have in common is they all implement this type over here called observer, which has a notify method with the stock and whether we're buying or selling that stock. Right? So we could add observers and um, we could remove them and and the stock market code will not have to be modified, right? So it's similar to um, the strategy in that it's open for extension, closed for modification. Okay?
Wait, so is observer based?
It's
Oh, sorry.
basically the strategy. It's just that it's a special form of it.
So it's just interfaces and composition plus a notify method or an update method.
It's basically strategy, and all the observers have this interface.
Okay,
You have the
I see.
common interface. It doesn't have to be notify, but typically it's called notify. But yeah,
Okay.
I think actually I showed you that in visual uh, in Visual Studio in C Sharp. I think I showed you that they also use observer. Um, they don't call it the observer pattern, but it is basically it is observer pattern where they have you could you could ask to be notified when, let's say, somebody clicks something, and you could add and remove people listeners. Right. So that's actually how Visual Studio in Windows, um, that's how it works. That people get notified. They like register, say, "Hey, tell me when you get clicked," or "Tell me when you get double clicked." "Hey, tell me when somebody types in a character," or the mouse goes on top of it. So I want to be observer for those type of things, and there's a standard interface that that those methods have. Okay, so that's actually the observer pattern is actually used by Visual Studio. Okay, and probably a lot of other programs without really noticing it, you see they actually do use it. Okay, so okay, so that is observer, and um, then we did eight. Um, so this is basically we spoke about the oh, then we started the solid. So these are the first four. Then we spoke about preferred composition, open closed. Then we said uh, S stands for single responsibility principle, which is we said that code should only do one thing, meaning which number one, it's easier to understand. Number two, when you modify the code, if it doesn't do too many things, then you won't break too many things, right? So for example, we said that this is a bad idea because it's doing two things, right? It's adding two numbers and it's printing them, right? And then the O stands for open close principle, which is number six we did above. List of substitution, where we said that the um, that you should be able to set a um, a you should be able to change a parent with a child and get the same result. But the problem is that if we have the example we gave, the famous example of a square and a rectangle, that if a square inherits from a rectangle, then you'll get different results um, if you if this if we pass in a square. Okay? Even though square inherits from rectangle, we'll get different results, right? Because the square, the sides are always the same. While with a rectangle, they don't have to be, right? So this will work differently with a parent and his child. And according to Liskov, that's not good. Okay? Oh boy, this is really bad spelling. Um, Okay, interface segregation principle is a fancy, it sounds complicated, but basically what it says is that your interface shouldn't have for example, email. It shouldn't have like add and let's say if an interface called math, so you should just keep things that are related to it within it. So you shouldn't have like email, right, or print result, right, which don't really right, that's not really doing math, right? That's something different. That's for emailing result. So you should move that to somewhere else. Okay. So for example, over here, I moved it to its own interface. And then we have dependency inversion principle, which is that we want the um, the basic idea is um, that we should be as general as possible, right? We don't want to limit our methods to only taking specific types, but we want to be as general as possible because then when we want to pass in other words, like I gave the example of looking for a cook to make breakfast, to make, let's say, to make oatmeal, right? You don't want the require the cook to, you don't want to like advertise for a cook that knows how to make French souffle, right? Because that's not what the job is. So why should you require that? Right? Obviously, if you can make French souffle, you can make oatmeal. But if all you need is oatmeal, you just advertise oatmeal. So basically, the same idea is with a method that if all you need is a basic method, a basic type, don't require a more narrow type, a more specialized type. You should say, I could use anything that does the more general type. And then, like with the cook, for example, you could have more when you advertise, more people will be able to answer that advertisement than if you have a narrow, um, looking for a cook who knows how to make French souffle when you really don't need that. That's not really what your requirement is. So you should always be as general as possible. That's dependency inversion principle. Okay. Um, why it's called that, it's not that important. Dry means don't repeat yourself, which is very important, meaning that you should always have logic in, for example, over here, I'm reusing this logic of adding two numbers when I'm adding three numbers, right? So over here, I'm reusing the logic of adding two numbers when I'm adding three numbers, okay? So, so all the logic of adding two numbers is in one location. So for let's say find a quicker way to add two numbers than let's say I1 plus I2, let's say I could maybe do bit shifting or something like that to add the two numbers. So then I would just have to change it over here, and then automatically the change will propagate throughout the program. Yagni means that there's a cost associated to to keeping old unused code around, and so basically Yagni says that get rid of it because number one, if you have unused code, people are going to look at it and that before realizing it's not being used. And number two is even if it's not being used, it has to be maintained. So just get rid of it. So why spend money on something that's not being used? Okay? Why waste time and why spend money if you're not using it? Um, and this we start with the class diagram. Um, let's see if we have we're up to seven, I think. Um, no, we did that. We're up to eight. Uh, so we're up to nine. Wow, we're moving fast. Class nine. Um, this is just basically a review. Uh, okay, this is basically um, showing the idea of dependency inversion. Um, so I'll show. Let's look and see if I have the project. Um, okay, so maybe this is it. Let's see if this is it. Yeah. So for example, over here, let's say I have a checking account, right? So if I have it relying on SQL Server database, right? Then if I change the database I'm using, right, then um, I'm stuck, right? So rather than relying on SQL Server database, what we do is we rely on a interface instead, right? And then then we could pass in then if we change the database type, we don't have to change the code, right? So for example, over here, where was it? The checking account, where we store the balance, right? We don't care what type of database it is, right? Because it's a generic, it's a abstract type, right? And so whatever database is passed in, that's what we're going to use. So for example, here we could use checking account with SQL Server database. Here we could use it with a Oracle database, and it's all going to work the same. Okay? And the code doesn't have to change, even though we changed the database type, because both SQL Server and Oracle inherit from or they implement the this interface which stores the account information the account balance. Okay? Okay, good. Any questions? Okay, let's move on. Okay, that's there. This 20 class 10 is UML class 10. Okay, this is okay, there we spoke about different types of um, relationships, right? So basically, there's um, well, we didn't do the one over here realization, but we did it association, which means that when we're not specifying the relationship, we just have forget about the arrow, just there's a line between two objects. There's composition, where I'm sorry, there's inheritance, which is this type of arrow. Skip this one over here. Let me just maybe I'll cut and I'll edit it. I'll just get rid of that. Using um, hmm, it didn't copy it. Uh, let's see. It what happened? Okay, let's try copy. Okay, copy. And let's paste it. Copy. Not letting me paste it. Edit. Uh, okay, whatever. So the point though is that um, the point is that um, the point is that, okay. So the point is for ignore the one in this one realization. So we have inheritance, association, dependency, which is a dotted line, aggregation, and composition where it's similar. Does anybody remember the difference between composition and aggregation?
Was it aggregation like it can exist on its own, like either party, and then composition it can't?
Exactly. Very good. Okay. Right. And then we went through oh, so yeah. Uh and then oh yeah, and then we said what about dependency relationship is where, for example, um like let's say you have um an object is passed to another object as a parameter. So in that case there's a dependency, but it's not contained inside of it. Does that make sense? And then let's say I pass an account to a method which processes the account but doesn't store it. So it's not composition, right? But the relationship is there is a dependency, meaning that the, let's say, let's look at something, to instead of trying to, um, so like for example, uh, um, I don't even know what this is, but let's say look over here. So, um, over here, for example, right? It's a bad example. Let me, maybe one of these. Oh, wait, that one of these should probably have it. Uh, 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 they're all different ways to do the same thing. So, like for example, no, uh, let's, I'll just do a very simple example. Let's say we have um, uh, um, a method called process, the process account, and this takes as a parameter or process shape. I'll just take I don't know what it does. It's a public void. And let's say it does something with it. Okay. So um, um, uh, like processing shape. So in this example, S is not stored within this method, right? But it's still this method is dependent on the shape, right? So there's a dependency between between this method and the shape object. Okay? But it's not like over here where shape is inside of it, right? It's that's just passed in. So it has to know about it. So dependency means it has to know about it, but it doesn't necessarily have to be inside of it, right? Like over here, um, like like for example, over here, the uh, the circles inside of it, that's composition, right? The squares inside of it, that's composition or aggregation, right? But um, but oh yeah, here's a good example. But we have the draw method. The relationship between draw and shape is that draw doesn't contain, and there's shape is passed into it, and it just draws it. Okay, so the relationship is just one of dependency rather than composition, inheritance, or any of the other ones. Okay, that's basically the idea. Okay, um, so that is a dotted line. Um, then we have multiplicity, which is like, for example, a company employee. There's a there's the least amount and the most amount. So a company over here, an employee has has to have one company at most and a minimum at least one. And over here, in a company has to have at least one employee, but maximum could have infinite amount of employees. Okay, so these are the one means it could have one, no more or less, zero. to one means zero or one. This means many, zero to many, and this is one to many. Okay, so I think we're going to get more examples. Class 11. Okay, we did the factory pattern and we did the singleton. Okay, so does anybody remember what the factory pattern does and what the singleton does? What does the factory pattern do? It controls what? What does the factory pattern do? It controls which object is created, right? So for example, over here, I want to create a bike. So it only lets me create the proper bike, right? But over here, right, the idea is over here, I can only create my bike factory will only create the proper bike based on the age of the that I'm passing in. Okay. So I can't create the wrong, so it prevents me, sort of, it's for the programmer to prevent the programmer from accidentally creating the wrong object. So the factory is in charge of creating the bike. Okay? So if you're less than six, it returns this. If you're less than 18, it returns this. If you're 18 or over, it returns that. Okay. Next um what was the other one? We have factory and we have singleton. So the singleton pattern, what that does is it basically has a global, and we said there's two types of global. One is where it gets created when the program begins, and it's private. So the only thing that can modify it is this method. And then, what is this? Uh, oh, I forgot why I did that. I didn't actually do that. Cover that. Uh, uh, do I have another thing? Or that is it? Oh, I see. That's the one I did. Sorry about that. So over here, we have the get ID, which is the one we just said. And we also have this other type of singleton, which is only created the first time I need it. So the first time I call it, it checks to see if it's been created. If it hasn't been created, it creates it and returns the reference to that object, to that class. So only one will be created, but also will only be created when it's needed. Okay, then we have class 12. Well, we're getting there, which is we spoke about Agile and Scrum. Ah, so basically, we went over here and we spoke about the idea we spoke about in chapter 2, which was predictable progress. So over here, we estimated before each sprint how much we could get done. And eventually, what we estimated, which was the light blue, was what we actually did. So we got really good at predicting our progress. Here also, it shows that even though it's not showing what we predicted, but it's showing that every sprint, where except for sprint number 3, which was messed up because we went backwards, but every sprint pretty much we did the same amount of work. We did about 90 units of work. Then we spoke about if you want to know what to do, you always do high cost, I'm sorry, high value, low cost. Then you do high cost, high value. Then you do low cost, low value. And then you do high cost, a low value. And then we just spoke about the different ideas of incremental. Um, and we spoke about Scrum. We spoke about the idea that there's a product owner who's there. We spoke about there's a Scrum Master who theoretically is somebody from the team who's in charge of that sprint. And there's a product backlog, which is at the wish list. And then we have the sprint backlog, which is what we want to do in this scrum or sprint. And then the scrum, it comes from the daily stand-up meeting, which we have every day. And then also potentially after every increment, we have a product that could be released, right? Because the product should be fully tested and working. Then we spoke about that we could divide our requirements into stories, user stories, which consist of four parts: who, what, why, and UAT. Who is who's going to be using it, meaning like what type of person. What is what do they want? Why is why they want it, and the reason why we ask is because maybe the software it already does what they think they need it to do. And number two, it gives the user, maybe we could give them other ways of doing what they want. And the UAT, the user acceptance test, is where we show the user how the software will be tested to see how if it works. Meaning they tell us, we say, how are you going to use our software to see if it makes you happy? Right? What are you going to do? Like for example, you're buying a car and you want it to be fast. How fast does it have to be in order to make you happy? Right? So you'll say it has to go 100 miles, 110 miles, 150 miles, whatever it is. But we want to know what it is that you're going to do to see that you're happy. And these are more of a example of a user story. And that's it. Okay. So I know I went kind of fast, but I think you could pretty much chapter three. It's all in the book, so you just really just gotta go through this quickly. It's um, it's not very complicated, just different ideas. Okay, okay. So I'll see you on Tuesday evening. Okay. If you have any questions, email me. Okay. Any questions right now? Okay. Okay. I'll see you guys on Tuesday night then, or I'll look at your emails.
Thank you, Professor. Bye bye.
Yeah.
Thank you, Professor.
Okay, good night.